Hey everybody, welcome to our lesson for today. We are going to be reviewing for our quiz. We're going to go over graphing standard form, vertex form, intercept form. We're going to convert between all three different forms in our equations, and then we're going to do some graph matching just to make sure we're ready for our quiz. So the first three numbers, 1, 2, and 3, what we are doing, well, for the first 9 actually, we are going to sketch the graph and identify how it opens, the equation of the axis of symmetry, the vertex, x-intercept, and y-intercept. Okay, so knowing what function we're looking at is very helpful. So looking here at number 1, we look and we see that this is in standard form. It's in the form of y equals ax squared plus bx plus c. So that tells me that the first thing I probably should identify is the axis of symmetry. Where is the middle of the graph? So if we remember, to find our axis of symmetry, we're going to do negative b over 2a. And every time you plug something in for those numbers, this can be x equals, it's an equation, we should put those in parentheses. So we are going to say that our axis of symmetry is going to be at negative, and our b value is negative 8 over 2, and our a value is 1. So our axis of symmetry is going to be at x equals 4. That means that we could draw this imaginary dotted line going through the x value of 4. Okay, we need the x because it shows that this is a vertical axis of symmetry. It has vertical symmetry like across this vertical line. After that, it would probably be helpful for us to remember that our vertex should fall on this axis of symmetry. So that means, sorry about that, that the x of our vertex should, the x of our vertex should be a 4, so we just need to find what it is. Guys, the easiest way to graph any function is to make an xy table and to plot your points. Well, the question is, what values do we want to look at on our table? Well, we know the middle of this graph has to have an x of 4. So as a quadratic, the left and the right hand side should mirror each other. So if we pick 2 just smaller, or just to the left of the 4 on the x, and we pick 2 just to the right and bigger, we can use our table feature. So table, type in our function, x squared minus 8x plus 13, and we can tell the table, well, let's start at 2, and we're going to step by 1, let it auto and ask, and we're going to get here that our numbers are 1, negative 2, negative 3, and then we should see that it repeats 2 and then 1. So 1, negative 2, negative 3, negative 2, and 1. We should definitely see the symmetry where the 2 outside, the top and the bottom one there, are at the same y value, and then the ones right next to the vertex. So here, right here, this is our vertex. So we can say our vertex should be at 4, negative 3, and that would be right here on our graph. We could go ahead and plot these other points too. So 2, 1 is here, 3, negative 2 is here. We have the 4, negative 3, 5, negative 2, and 6, 1. Now, I'm going to hold off on connecting these dots because we always need to make sure that we plot x-axis, x-intercepts. Okay, so if we have any x-intercepts that fall on this line, we need to make sure that we plot them and we say what they are. Okay, well, on here, the best way to find your x-intercept, okay, because we are given a quadratic, I don't want to sit here and try to factor this. I just want to do something that we know will work. Well, we know the quadratic formula will give us the answer regardless of whether they're whole numbers or not. I know that these are not going to be whole numbers because they didn't show up on my table. All right, so I'm going to say, let's do our quadratic formula, which says negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. All right, hopefully you remember how to type that in. I'll show you once here to remind you on the calculator. So we're going to do the n over d button, negative, put everything inside a set of parentheses, negative 8, plus, can't do the plus and the minus at the same time, so just do the plus, Then our square root, we did second x squared, negative 8 squared, minus 4, parenthesis 1, close parenthesis, open a new set of parentheses, 13, close that set of parentheses, arrow down, we're dividing this all by 2 times 1. Hit enter, it's going to give us the exact answer, which still has a radical in it, to make it a decimal so we know where to graph, okay? We are going to hit the toggle button right above the enter, and we see that it's 5.7. So we have an x-intercept at 5.7, comma 0, which is about here. And if we do it again with our minus, we are going to get a 2.3. So that would be about here. Now I can comfortably say, all right, let's go ahead and graph this. Okay? So remember, put arrows on the end, make sure you go through those dots. If you go through like your x-intercept of 2 and it's not close to where that 2.3 should be, you'll probably get points off. Okay? The only other thing, well, 2 more things we have to identify is our y-intercept. This is a standard form, so that means your y-intercept is going to be the c value, because y-intercepts are where your x is 0. So if we put a 0 in for this x and this x, that just leaves us with a 13. Okay, that would be way off the graph, up higher, so we're not even going to plot it. And how does this graph open? This opens up. It opens up because my leading coefficient right here in front of x squared is a positive, so it opens up. All right, so go ahead, pause the video here, do number 2 and number 3, make sure you identify all those pieces of information, then check your answer. All right, here is number 2. Make sure that you got what you needed. If you need to pause it so you can see it a little bit longer, that's fine. And here is number 3. Okay, so make sure you get a chance and you check those. Numbers 4, 5, and 6 are all in a different form, so I am going to do number 4. You guys are going to do 5 and 6. Number 4, when we look at it, we recognize that this is in vertex form, which means we should be able to identify the vertex right away. Remember, our vertex comes from this piece and this piece. Okay, we're going to use the opposite of this for our x, and this over here is going to be our y. So the first thing I would identify is our vertex, which is going to be 1, negative 1. Okay, so if we put that on here, it's going to be right here. Right, something that we know excuse me, about our quadratics is that the vertex falls on the axis of symmetry. So we know our axis of symmetry should go through all the x's of 1. So that means right here. Okay, this allows us to know where to go on our table. So on our xy table, so we can plot it, the middle should be at 1. So we need 2 numbers smaller, so 0 and 1, and 2 numbers bigger, 2 and 3. So I'm going to go ahead, I'm going to grab my calculator. Okay, I'm going to go to the table. Oops, I'm going to go to the table and I'm going to clear out the old function. Now we're going to put this new one in, negative 3, parenthesis, x minus 1, close parenthesis, square, then minus, that's over here on the right, then a 1. This time we're going to start our table at negative 1 because that's where we determined our x needs to be. And we're going to find that we get a negative 13, negative 4, negative 1, and then it mirrors each other. So negative 13, negative 4, negative 1, negative 4, and negative 13. All right, so go ahead and plot these. When x is negative 1, our y is negative 13. When x is 0, our y is negative 4. We already have this one plotted because that's where we said our vertex was, so that's good. Then 2, negative 4, and 3, negative 13. So we see here that this graph is going to open down. We also know that because this leading coefficient right here is negative, so it tells us it's going to open down. Okay, when we're looking at our x-intercepts, do we need to plot any? Well, look, the vertex is below the x-axis and it's opening down. So it's never going to cross the x-axis, so there are none. And then our y-intercept, it's here. It shows you when x is 0, our y is -4. So we have everything that we need. So I'm going to go ahead and connect my points and put arrows on the end. Okay, number 5 and 6 should be just as easy. So go ahead and pause the video now and do 5 and 6. All right, here's number 5 and number 6. Okay, take a second, pause it if you need to. Notice on these tables, 0, x of 0 to get your y-intercept is not showing, but you can just scroll on your table on your calculator to find what that y value is. So like 0, -18 for number 5, and sorry I didn't write it in for number 6 is 0.19. Okay, so just make sure you know how to get those by scrolling. All right, the next three, numbers 7, 8, 9, and 10, 7, 8, and 9, these are all in a different form. These are all in intercept form. That means it's going to give us the x-intercepts from the very beginning. Okay, so all we're doing is putting a 0 in for y, and then it's back to like we were solving. So all we're really doing is setting these two factors equal to 0. So when we set the factor equal to 0, we get a +3, and when we set the other factor equal to 0, we get a -2. So our x-intercepts, to begin, are going to be a 3, 0, and a -2, 0. So that would be here and here. Okay, well, what's nice about our x-intercepts is we know that they fall the same distance from the axis of symmetry. So the axis of symmetry needs to be right between them. So all we need to do is take these two x-intercepts and we're going to find their distance. Okay, so if we add them together and divide by 2, it's going to give us where our middle is. So this is going to give us a 1/2. So this is our axis of symmetry. So axis of symmetry should be at 1/2. So that means it's going to be here. I know it's not pretty because it's not right on one of those lines, but that's okay. That also means that our vertex is going to fall on that axis of symmetry. Okay, so on our table, we're going to be a little bit careful on this one. So x, y, I know we want to have like -2 and 3. We want nice whole numbers. That way we're plotting good, nice whole numbers. Okay, but we are also going to want to put that, the axis of symmetry on there. So let's just do -2, -1, 0. The 1/2, which is our axis of symmetry, this one's going to actually have 6, then 1, 2, and 3. Okay, so I'll show you what this looks like just to make sure you guys are comfortable with this. We're going to go to table, we're going to clear out the other function, we're going to type this one in parentheses x minus 3, close parenthesis, open a new parenthesis, x plus 2. We're going to start this at -2. Okay, and right now we're just going to get these. So it's 0, -4, -6, 0, -4, -6. And then if we scroll, notice how the next number is not the 1/2, it's the 1, and then it's a 6, -4, and 0. That's -6, -4, and 0. Now, how do we go back and get the 1/2? We'll go back to table, hit enter. This time, let's make our start value 1/2, or 0.5. Okay, so this one will tell us that it's -6.25. Okay, so now we are going to say, okay, our vertex is going to be at -6.25. So we can go ahead and we can put these points on. We already have -2, 0, so -1, -4, 0, -6. Now on that axis of symmetry, 1/2, it's going to be -6.25, so just a little bit farther down. Then 1, -6, 2, -4, and 3, 0. So what's nice is we have our x-intercepts plotted. We have our y-intercept. Ooh, what's our y-intercept? Well, when x is 0,